Let's kind of go over what we did yesterday, because I want to make sure that you guys have everything that you need. So, a standard form would be this. Okay, so let's start with this. So at x equals -5, I want that to be my 1, 2, 3, 4, 5. That's going to be my vertical asymptote. I don't like this because it's off the graph. It's okay. Okay. Restart, right? Let's do this. Okay. So at -5, 1, 2, 3, 4, 5, that's going to be my vertical asymptote where x equals -5, because that would make it 0. So I'm going to write that is my vertical asymptote. I should have graphs for you that you could have pasted into your notebook. That would have been nice, huh? And then the -7 would be my horizontal asymptote. One. -5. 1, 2, 3, 4, 5, 6, 7. And finally, this 4 out here, you should be color coding with this too. I forgot it was up here. This 4 out here is the scale factor for my reference point. Scale factor for my reference point. So instead of going over 1, up 1, I'm going to go over 1, up 1, 2, 3, 4. From the intersection of my asymptotes. And I'm going to go to the left, over 1 and down 4. 1, 2, 3, it's a little bit off the map, which isn't a big deal, right? And then it's right up against, and then when it hits that reference point, it starts to slowly taper down. Same thing here. And that was yesterday. Are we good? Yeah. I'm sorry. I meant for you guys to be taking the notes the whole time. I know. Well, I'm not showing you anything new. When I show you something new, no writing. But this is just from yesterday. Okay. So now that you guys got notes down for yesterday, or some of you, let's play with this a little bit. Okay, so get your graphs out, those green graphs with the sheet protectors on them for whiteboards. And can you graph x plus 2 for me? do 4. Graph that on your green board, please. Okay. So I know that my vertical asymptote, which is right here, my vertical asymptote is going to be x equals -4. So I go over 4. 1, 2, 3, 4. My horizontal asymptote is 0. I think I had this in blue, right? This was the blue part? Yeah. There's nothing there, right? So it's just y equals 0. There we go. Y equals 0. I like that blue. It's pretty. And then my scale factor is out here in front. It's 1. So I'm just going to go over 1, up 1, and over 1, down 1. And there's my graph. Okay. Let's change some stuff. Let's do this. Let's do +4 and +4. What does that look like? Show me on your whiteboard. When it's nothing there, it's 0. Oh, this is 1, yes. When there's nothing there, it's 1. Let's put that in front, right there. Bing. Okay. So, this one, all this goes away. Alrighty. So first we want to do our asymptote. So our asymptote, our vertical one is to the left 4. Where's the x? 1, 2, 3, 4. Wrong one. 1, 2, 3, 4. And then this one says to go up 4 for my horizontal. 1, 2, 3, 4. It's not down 4, it's up 4. If I were to rewrite it like this, then you'd have a -4 over there. That's that whole transformational form that I think some of you are getting mixed up with, right? Okay. So if it's in this form on this side, you go up 4. The only one you go down or you go to the left for is the one that's in the parentheses, because it's like a 0. Does that help? Yes. These two are the same. Right here. These are equivalent. Yes. Okay, so now I just have to do my branches. So my branches are going to be from the intersection of my asymptotes, over 1, up 1, and over 1, down 1. Now let's change this. Let's make this a 3. How is that going to change it? You don't have to file all this, because you know what? It's all first semester stuff anyway. We might as well just throw it away, yeah? Yeah, we can just clear them out. Yeah, just leave them. And I'll see if they want to clear them out. And then if they don't, we'll just throw it all away. Thank you, though. I appreciate it.
You always start next to that.
You always start at the intersection of your asymptotes. You're starting at the intersection of your asymptotes. Okay, can I see? It's just your graph is turned wrong.
Oh, yeah.
So I was confused. Okay. Can I see? Can I see? Fantastic, fantastic. Everything looks really, really good. I think everybody's almost got it. Okay. So instead of my reference point being at 1, 1, if I have a scale factor of 3 from the intersection, Philip, from the intersection, I go over 1, Philip, looking, up here, over 1 and up 1, 2, 3. And over, that's why I'm asking you to look up here. Over 1, down 1, 2, 3. All right? Okay. Thumbs up, thumbs down. I think we're almost at 100%. Thumbs up, thumbs down. I don't know unless you tell me. Okay, good. Let's move on. Oh, I know. We missed one. What did I miss? What's the only thing I didn't cover? Negative. So if it was negative, instead of it being here, I think I will actually just reflect it. If I put a negative in front of there, it would be down, instead of up 3, 1, 2, 3, it would be down 3. 1, 2, 3. And instead of going down, I would go up 1, 2, 3. That's what that would look like. Okay? Miss Wiz has a student that says if it's positive, it looks like a positive slope because it's in these two quadrants. And if it's negative, it's in these two quadrants. Right here, negative looks like a negative line. Does that make sense? I like that a lot. Okay. Let's rewrite these. Okay? All right. So this looks almost exactly like what we've been working with. But I want to put it in this form right here. So actually my K is in the front. I'd like to use the commutative property and move it to the back. So I would rewrite this as 4 over x plus 2 plus 2. And now I could graph it, right? Here's another one. 2 over x plus 2. And I'm going to put the 3 in the back. But this one's not done. Because my scale factor, if I were to put it in this form right here, I have a scale factor that needs to be pulled out. The 2, exactly. Let's just rewrite it here. So if I were to pull the 2 out, it's like saying 2 over 1 and then we're going to add the 3. And 2 over 1, if I want to make sure that I factored out correctly, I could just try and distribute. 2 times 1 is 2. And 1 times x plus 2 is x plus 2. But I really don't have to write it. I could just write it like this. 2. 1 over x plus 2. Plus 3. Good? You guys ready to try one? Can you guys do this one for me? On your whiteboard, please? This one right here, the purple one. Please don't erase. Okay. So, first, I'm going to use the commutative property and put this -1. And at the same time, I'm going to factor out a 3. Right? Because there isn't a coefficient in front of x if I want it in this form. So I'm going to factor out a 3, and that gives me x minus 1. And then the positive 1 goes behind. But I'm not done because that means that I've got a scale factor of that 3 needs to come out. But it's in the denominator. And the -1 needs to come out to remind me that this is a negative graph. And then I'm left with 1 over x minus 1 plus 1. So now I'm going to double check it. The -1 times 1 makes -1. And 3 times x minus 1 is 3 times the quantity x minus 1. You guys ready to do one on your own? Try the blue one. 1. Okay. I'll use blue this time. Okay, I'm going to go this way this time. All right, so I've got 2. I'm going to put the 1 behind, factor out a 2, and then put the 1 here. Then I'm going to factor out that 2 in the denominator, and at the same time, I'm going to bring a 2, factor out a 2 in the numerator as well.
Oh my God, it was so close.
So 2 divided by 2 is 1, which I don't need to really write it, right? Good. You guys want another one?
Wait, why do you do the... Why are you...
Yes, Florencia. You're factoring out a 2 from the denominator and a 2 from the numerator. Hey guys, check this out. You could see it here. Look. It's coming next. Monday. Okay. Right? Isn't that the same thing now? This one and this one? These both had a common factor of 2. They cancel out to make 1. But we'll be doing more of that on Monday. Okay, let's try another one. Let's see. This would be a good one here. Blue one. See the blue one. One. I think we still need a little bit more. Okay. I think I'll go this way. It's neater this way. Okay, so I'm going to switch them around. So I have a 1 over. At the same time, can I get you guys to stop talking for a second, please? I'm going to factor out a negative. I asked nicely. Thank you. Negative 2 times x plus 3, Florencia. X plus 3. And then minus 2. But I can't leave it in this form. I've got to pull out that negative 2, but it's in the denominator. Are you cheering yourself on, Philip? Good job. Okay, and now we can graph it. So it has a vertical asymptote of negative 3, a horizontal of negative 2, and a scale factor of 1/2, and it's negative. Okay, thumbs up, thumbs down. Do we want to graph it? Are you sure? Okay. Philip.
Wait, I got it right. I don't know why. Like, okay, why do you take out the negative 1/2? Like, I know what you're saying about the denominator, but how do you get the numerator?
How do you get the numerator? If there's nothing there, it's a 1.
Okay, I got that. So, like, what if it's...
Because 1 times 1 is 1.
So what if it was, like, a 4 on top?
Then there would be a 4 here. If this was a 4, then this would be a 4, and then it would be negative 2
Okay.
times 1 over x plus 3.
Okay, that makes sense. It's always going to be 1 half.
Yes. So it always has to... Too much talking. Uh-oh, now I messed it all up. So this needs to be a 1. This needs to be a 1. Let's go back up to the top. It has to be in this form with a 1 in the numerator here. There's no coefficient here, right? And then, so whatever's left on the outside, that's our scale factor once we factor everything out. Make sense? Better? Okay, good. You want to try this one? You want to try the blue one? Okay, do the blue one. No. You don't want to leave right now, Florencia, I'm telling you. So being at 90% is good. You guys are doing good. All right, so first I'm going to change it to be 4 over, factor out that 2, x minus 2, and then the 4 goes in the back. And the last thing I need to do is factor out the 4 in the numerator and the 2 in the denominator. Then I've got that standard equation that's got a 1 in the numerator on the inside of the parentheses. And then x minus 2, and x doesn't have a coefficient anymore, plus 4. So this really is just 4 divided by 2 is 2. So scale factor of 2. Okay, so if you're still having trouble with it, then maybe you could just stay like a couple minutes after school and we can finish that up. Okay. Okay, how many different ways or notations can we represent 22 divided by 5? Show me on your whiteboard. How could you write 22 divided by 5? So I saw most representations. So we could do 22 divided by 5 horizontally. We could do 22 divided into 5 groups, right, with that division. What do we call it? A bracket? No. A house. Or 22 divided by 5. A prison. In junior high, we say, in 7th grade, you say, whoever gets home first gets to park in the garage. Uh-huh. Oh, I like it. Okay. So let's go here. Before we even look at this. Okay, 5 divided by 22. Let's actually do the math on this one. So 5 goes into 22 4 times. 4 times 5 is 20. Draw the line, change the sign. We've got 2 left over. How do we write that? Sarah, how do we write that?
4 minor 2. Or no, let's do that.
There's lots of, so write it down. Write how you would write that remainder. How would you write the quotient? 3, 2, 1. I saw lots of representations, and I liked a lot of them. We could write 4 remainder 2, right, if we were in 6th grade still, right? That's what you're comfortable with, right?
I never learned that way.
No, you never heard it. Okay, so we have 4. What this is asking us is if I had 22 pieces of candy and I wanted to divide them into 5 different table groups, right? I could give 4 candies to each table group, and then I would have 2 left over, remaining 2. Let's see. We could write it like this: 4 groups of 5, or 5 groups of 4 is 20 with 2 left over. Or we could write it like that: 4 and 2 out of 5 left over. Okay, I'm surprised. Okay, so this means I have 2 left over out of a group of 5. So if I wanted to make a whole group, wouldn't I just have to add 3 more out of 5 to get 5 out of 5, and then I have myself a whole another group, right? Okay. This is the one we're going to use right here. Right here. So let's look at this. Go back up here, and I'm going to divide this one. It is. It's going to be a lot of fun. So how many x plus 3's are there in 2x plus 8? Well, I know there's 2 x's. 2 times 3, right? X goes into 2x 2 times, right? So 2 times 3 is 6. And 2 times x is 2x. Draw the line, change the sign, and I'm left with a remainder of 2. So if we were to write it this way, it would be 2, remainder 2, right? if we were to write it this way, I need a purple. It would be x plus 3 times 2 plus 2. And if we were to write it this way, it would be what? It would be 2 plus 2 remainder over x plus 3. Does that look familiar? It looks like what we've been doing. So when you guys were doing long division, or specifically, I'm going to show you. What? This ties into what we've been doing all along. Remember this?
Oh, my favorite long division.
So guys, when I got a remainder of 4, or negative 4, this is what it would be. Remember I told you that? I only put that there so you could see it. This is what that would be. So that negative 4, first of all, the quotient's right there. So that's 2x squared minus x minus 3 with a remainder of negative 4. I'm going to say plus negative 4 over x minus 3. So this graph right here actually looks like this. You ready for it? I think it's not this slide, it's the next one. So I showed the long division part. So it looks like this. Graph looks like that. Where an asymptote right here, you can kind of see it. The asymptote's at 3, so it's over 1, 2, 3, right? This part of the graph right here, this negative 4, is probably part of this graph here, and this one is probably part of this graph here, but it's all the same graph. I'm guessing that this part right here is over here, and we can't see all of it, right? It's not something that we're normally used to seeing, okay? And you don't have to do anything like this. I'm just relating it to what we used to do, okay? Don't get scared. When you see what we're going to do, you're going to be like, this is easy, okay? I'm just showing you an original problem that we had and what it would look like. Yeah, we're going to do these, guys. You ready? I'm like, you don't see it? You guys can't see it?
No.
Okay. So that's perfect. So now when I teach you how to do this, you're going to be like, phew. Okay. You get it?
Pi is irrational.
Because pi is irrational
Pi is not.
and I is not real. It's imaginary. Okay, that went over better in 5th period. Okay. All right, so let's look at something a little nicer. Okay? So, this would really be asking, this would be, if I were to rewrite this, it would be x plus 4. I'm just going to write it here. I'm going to just cover this up. I don't need it. So if I have x plus 4, and I'm going to divide that by x plus 3, what I'm really asking myself is if negative 3, right, is a 0. That's what we were doing before. Remember that? Yes, Mrs. Moore. It's not going to be. We're going to get a remainder, and then we're going to be able to graph. It can only go in. Okay, wait. I'm glad you're catching on really, really well. You are. But I want everybody to hear the process first, okay? All right, so x plus 3 goes into x plus 4 only one time. Need some color. Looks so bland, this page. So 1 times 3 is 3, and 1 times x is x. Draw the line, change the sign. I'm left with a 1, a remainder of 1. So my answer is So h of x is equal to 1, the quotient is 1, with a